Okay, let's go ahead and try a tank example. So we have a large tank holds 300 gallons of brine solution with 40 pounds of salt. So 40 pounds of salt. I know that looks like 401 maybe. Sorry about that. I should have left a space there. A concentration of 2 pounds, not 21, 2 pounds per gallon is pumped in. So let's underline that, in at a rate of 4 gallons per minute. The concentration leaving the tank is pumped out, right, or drained at a rate of 3 gallons per minute. And the question is, how much salt is in the tank after 12 minutes? Okay, so we definitely, hopefully you guys are seeing an inflow rate and an outflow rate. And the differential equation that we're going to use is going to be the one I wrote down in the video right before this one. And it's going to be dx dt, which is going to be the difference of Ri, the difference between Ri and Ro, where again Ri is, or R sub I is the inflow rate, and R sub O is the outflow rate. And the inflow rate is actually not too bad. The outflow rate is where it's just a little bit trickier. So let's go ahead and write, let me make this. Okay, so this is our differential equation, and the goal is, right, we want to solve for x of t, because we want to know the amount of salt in the tank after 12 minutes. Well, then it's just really going to be x of 12. But we have to determine the solution to this differential equation first. Okay, so let's go ahead and start by writing, let me move this down just so I can keep referring to it. And so we have Ri, and so we have Ri, and that's just going to be the product, right? That the little Ci Ri that I wrote down again in the last video, but it's just a product. Well, the product of what? Well, it's going to be the product of, so it's a concentration, we're focusing on the inflow rate of 2 pounds per gallon. So let's maybe write that in. So 2 pounds per gallon, and it's pumped in at a rate of 4 gallons per minute. So 4 gallons per minute. And notice I wrote my units in fractional form because then this is really nice. Then our gallons cancel out, and then we're just left with 8 pounds per minute for the inflow rate. So hopefully that was pretty easy. Now our RO, okay, well that's also going to be a product. And it's going to be the product of a concentration, right, times a specific rate. Okay, now the amount of concentration, this guy, this is really your, if you're looking at your book, let's see, in your book, it's your C naught of T. That's what it's equation 17 on page 52, if you'd like to look at that. So this guy is going to be my, my C, or CO of T. So that's the amount of concentration. And so we know it's going to be, we're going to divide by this, or divide by two quantities. And here, now remember, the number of gallons is this guy right here. So it's not going to be 300, right? So the large tank holds 300 gallons. But I know it's not just 300 here. I know it's going to be something divided by something. Because the solution's being pumped in, right, at a rate of 4 gallons per minute. And then it's being pumped out at a rate of 3 gallons per minute. So after every minute, we have 1 more gallon in the tank. So hopefully that makes sense. So I'm going to, so my numerator is going to be, well, if you're looking at the book at the formula, it's just going to be, it's x of t, it's a function of t, or I'm just going to write it as x. And then the denominator is going to be the volume, the V of t. And what's the volume? Well, okay, we know it's going to involve 300, right? It's not just 300. It's actually going to be plus, and let me write this in maybe pink. So that's, well, obviously that's a 1. So 1t, or we can just write 300 plus t. But I wanted to write the 1 in pink to emphasize the 1 gallon after every minute, right? And where t, of course, is the number of minutes. And this is going to be, we're going to multiply this by 3 gallons per minute, right? We have this guy, because we're talking about now the concentration leaving the tank is being pumped out, okay? So we're talking about the outflow rate. And if we just simplify this a little bit, we obtain, so we get, and actually I should write, I forgot, this really should be, maybe write in a different color just because I forgot it. I really should have a pounds per gallon, right? These are rates. And now my gallons are gone. And so I am left with 3x divided by 300 plus t. And I'll just go ahead and write that in parentheses. And again, this is pounds per minute. So I have my RI and I have my RO. So now it's, I mean, we can construct the differential equation. Let's just insert our guys here. And so we have dx dt, right, is equal to RI. Well, that's just 8. Right? It's pounds per minute, but we can ignore the units. 8 minus, and then we have our outflow rate. And that is just 3x divided by 300 plus t. And we also know from the problem, x of 0 is 40, right? Because at t equals 0, right, there's 40 pounds of salt in the tank, right? That's our initial value. And let's see, it is right here. And I mean, that's pretty much it. The challenge is to construct the differential equation. And in section 1.5, we learned about the integrating factor. So we are going to be using the integrating factor to solve this differential equation. And notice that this guy is actually a linear differential equation. You actually can put it in the form, let me just go ahead and write this. So we have dx dt, but the general one is dy dt plus, remember, p of x, y equals q of x. So we can rewrite this guy in this form. So I'll go ahead and stop here, and I will solve the differential equation in the next video, since I'm already at 8.5 minutes. Hopefully that made sense. Flip to the next page, and I'm just going to write my dx dt again. I'm sure you have it on your paper, but just so I can refer to it. Okay, so that's a plus and that's a t. Okay, so again, the goal is to solve this differential equation for x, which means